Hi, I'm Markku. I'm from Helsinki, Finland, all the way from Europe. I'm the founder and CEO of MeOnTrust Inc. and MePIN is our product and brand name. So we are a mobile security and authentication specialist company. A little bit background about us. We've been around for 6 years developing this mobile authentication solution. We work in the telecom sector with mobile operators, and we work in the financial sector with banks and credit card providers. Obviously, GlobalSign is our partner, and our solution is PKI based, so we work with the best in PKI. I think we all agree that passwords are not enough anymore, so we need something better. There's just way too many passwords, and people are forgetting them all the time, and stealing and leaking and breaching and so on. So traditionally, this password problem has been tried to solve with using OTP tokens or smart cards or something else, even SMS codes being sent to the users. This is usually very clumsy and sometimes even very non-secure, like SMS codes can be kind of taken over from the device by malware and so on. So come to the rescue, biometrics. Biometrics has been really growing now the past couple of years due to the introduction of the Touch ID on the iPhone. So now biometrics is everywhere. But biometrics really is about convenience. So biometrics, you don't have to remember anything. You just come up and you show your face, you swipe your finger, and you're authenticated. So it's not really about security. It's about convenience. Of course, there's several different biometric solutions, from fingerprints to face recognition, to voice recognition and iris scanners, and etc. But the basic principle is the same. It's something you are that authenticates you. But actually, biometrics are problematic. There's a few kind of general issues with biometrics. They're not really secure unless you have special equipment to capture the biometrics. So when you talk about smartphones are typically kind of all-around devices. Cameras are not so perfect for capturing your iris or face and so on. The biometrics can be stolen, so fingerprints can be lifted from you leave fingerprints everywhere when you touch things. So these things can be stolen. Your face can be photographed, can be taken a video of your face, and your eyes can be also taken into a video and picture. So your credential can be stolen. There are some privacy issues. So if you use your biometrics for authentication, if you collect all the users' biometrics into some server somewhere, and what happens if that server gets breached, then you are suddenly really in big trouble. And there's no way to revoke. So if you only use your biometric to authenticate, how do you revoke? You go to plastic surgery or change your fingers or whatnot? How do you revoke your credentials? Then there are some details on the technical side on the smartphones that are problematic. Touch ID on iOS, very nice, very convenient, and we all use it every day to log into our smartphone. However, there is a problem. The Touch ID API doesn't tell me, or the app developer or you, that whose finger it was. So there are cases where people are registering the animal paws or the gloves. So they use at least in Finland, where there's cold weather, people learned that there's a nice trick. You wear your favorite clothes and you register the glove fingerprint into your iPhone. So when you pick up your iPhone, you don't have to actually take off the glove and put your finger, because you can just use the glove, and it works. So there's no way on the iPhone to know whose finger it is. And this becomes also an issue when you use and want to use biometrics for things like payment authorization and things like that. So anybody could be registering the finger into your device, and the service provider doesn't know whose finger it actually was. There are some camera quality issues on a face recognition. So Android phones, there's of course a lot of Android phones, different type of camera quality in there. Some camera quality cannot really capture the face recognition well, or iris scanners. And lighting is affecting the face recognition. So if you're here in a bright light, it works. If you go in a darker place, then suddenly you have to try to find how can I authenticate with the face. And there are some speed issues. So fixing this face recognition, there are solutions that are using kind of 3D face recognition. So how they work is that you hold your phone, you take a 3D video, and it kind of looks at from different angles your face and then recognizes you. That's fine and that's nice and it's more secure than just the face, but then it becomes very slow when you have to do this every time, scan your face. So there are some problems with biometrics. But there are some good solutions to kind of overcome these problems. So what we are doing is we have a smartphone app authenticator technology that integrates biometrics. So how this works is that obviously we are using PKI. So user installs the app. The app actually generates the PKI private key, public key pair in the device and ties that key into the actual device. So the mobile phone becomes the main factor. So something you have, your phone. And then we use the biometrics to actually as a key to the key. So you have the PKI key, which is your main factor, and your certificate, but then you use your biometrics to open the key and digitally sign transactions with your private key. So this way, the biometric actually becomes the kind of the last mile or last inch of the authentication. So that's the second factor. Our solution also supports dynamic authentication policies, so there's 4 bullets there. So every transaction, when you need to authenticate, you can choose the level of authentication needed. So it could be just a simple tap for 2-factor authentication, or PIN code, or fingerprint, or face recognition, and so on. So depending on a level of assurance you need, so you can choose which authentication method. So how the basic setup works is that an online service actually integrates with the technology on the backend side with an API. So there's always a server and a client, and the complete setup is run by PKI infrastructure. And it's out of band, so you could log into your online bank or service in a PC or phone or tablet or any device, TV or Alexa box or whatnot, and you use your mobile phone and your biometrics to authenticate yourself or authorize transactions like payments. The app itself doesn't have to be a MePIN app. It can be a branded, customer-branded app. So we work in the telecom sector. They are building their own ID apps and publishing them to app stores. So the user who subscribes to a Verizon or your home country operator can download the app, and that becomes the ID key to authenticate. In some sectors, they already have apps, so we have a SDK that you can embed it to your existing app and enable biometrics into your existing app. The overall security is not very simple. There's a lot of things, of course, going on, and since we do a software smart card, we need to be deploying several different security techniques to keep the keys safe and transactions secure. So what we have is called Active Transaction Authentication Core, kind of core system and protocol that talks from the mobile app client to the server, and they are mutually authenticated first. There's man-in-the-middle protection of all the time, that there's nobody middling something in the middle. There's some malware and attack protection in the device, protect the keys. But then during a transaction, when you're authenticated, the server is actually very active actively monitoring the device, actually twice during a transaction. So when you open the app calls the server checks that are you still okay, are you trusted app, and then when you actually authenticate yourself, there's another check that the server checks that nobody has been meddling with the app in between. So the basic kind of face recognition, fingerprint, and so on, that can be enabled very nicely and fast. At the end, I'll show you some advanced biometrics, what we announced actually this week here at the show. So we introduced a kind of concept called human recognition and user recognition. So human recognition means that the app recognizes that there's a human in front of it. It recognizes that the human is alive, so you're blinking and not just a picture. And you can define that, take a picture of that human when he's authorizing the transaction with a PIN code or password or fingerprint and so on. So it kind of overcomes the issue of that somebody can steal your PIN or lift up your fingerprint. It adds additional biometric into the transaction verification, and it happens very seamlessly. When you're entering your PIN code, it picks up your face and if the service provider wants, it can take the snapshot of your face and store it for a while for non-repudiation. So if somebody calls in that, hey, I never bought this Porsche, so there's a picture of who actually did this. User recognition works the same way, that during a transaction when you enter a PIN code or password, your existing registered face is recognized and authenticated, and only if you are in front of your device you can use your PIN code. So that kind of concludes my short presentation, short glimpse of things. I can here demonstrate things one by one if you like. I didn't want to do this if the network is bad here, but if you're interested, then I can show you some of these use cases. And obviously, GlobalSign, the best PKI in the world. We work with them, and working with them and with us, you can enable your services and secure your users. Thank you.